Okay, so let's get started. We're going to be taking a look at working with mechanical base idle control tuning found within our Link G5 and G4X systems. Now, our mechanical base idle control is the most simplistic way to control and work with our idle control routine here with the Link. Mechanical base idle control is going to be applicable only to a cable-driven throttle body. This is going to be assuming no drive-by-wire, and it's also going to assume that you have no idle control motor hooked up to your throttle body and intake manifold for a controlled vacuum leak. What we're going to have to do is adjust our throttle set screw to allow a certain amount of airflow into the engine, and then use spark feedback from the Link to allow us to get close to the desired idle target. So this is going to be a closed loop system. It is going to be taking a look at a desired target for idle speed, comparing it to our actual engine speed, and then making adjustments virtually to control the spark timing to get us to the desired target. So the system actually works really simplistic, but there are some details that we need to know and understand so that we can implement this correctly on the engine you're trying to tune. Let's jump in here. We're going to move from our basics page, and we're going to move across here into our idle area. And this is going to be where we can turn on our idle control with the Link specifically for our virtual spark feedback control. Now, before we do this, let's just talk about what we have going on with idle control. We discussed this in the last training module. When we're talking about idle control, we're talking about controlling the engine's torque output in idle conditions. If we raise idle torque, we raise idle speed. If we lower idle torque, we lower idle speed. So that concept's pretty easy. Things that influence and affect our engine's torque output are going to be our fueling that we're delivering to our engine, our spark timing, and then the airflow. Now, because we're in idle conditions and we're in a generally steady state type of environment, we don't really alter the air fuel target or lambda target at idle. We typically run at 14.7 or 1.0 lambda. So in that regard, that's not going to be a factor to consider and influence the engine's torque output. What we have to worry about is the airflow and the spark timing. Both of those have a substantial and significant impact on the engine's torque output. Now, what we'll find is, and we talked about this in the last tutorial, we have two forms of the idle control feedback within the idle control routine. We have a slow path and a fast path. So if we're talking about our traditional idle control with an idle control motor or drive-by-wire, we have the ability to vary the airflow coming into the engine. That's known as our slow path of control. That's our course adjustment to our engine's torque and idle conditions. So when we're talking about that slow path of control, we generally want to go in and use that kind of as a slower moving type of influence on the engine's torque output because we don't want an unstable idle speed in idle conditions. So the slow path gets its name slow path because if we have to move an idle control motor open or closed, or we have to move our throttle angle open or closed with drive-by-wire, it's going to take a certain finite period of time for that mechanical aspect to influence the idle speed and the airflow in idle conditions and ultimately impact and influence the engine's torque. So in that situation, it's a slow path or a slow way to control the torque and the engine and the idle speed. A fast path of control is used and known for spark feedback. So we have the ability to virtually change the spark timing instantaneously within the programming here with the Link. Spark timing has a pretty substantial role in the engine's torque output. So we have the ability to control in a very fast feedback manner the engine's torque using our spark timing. When we're talking about mechanical based idle control, our slow path of control or airflow is going to be through the throttle blade opening. So this could be a single throttle body or individual throttle bodies. We have the ability with an idle set screw to open or close how much that throttle blade is opened or closed to allow more or less airflow into the engine to allow the engine to make more or less engine torque. So that slow path of control, talking about our idle control here in the mechanical base, that slow path control is going to be a course adjustment for idle control and a course adjustment for the idle torque output. What we're going to have control over here is adjusting that throttle stop to get a little bit of a surplus of airflow, surplus of torque. We'll talk about that concept here in a little bit. Then we're going to use our spark timing feedback from the Link to get us at or really close to the desired engine target. So it's going to move the spark timing around, either advancing it or retarding the timing, so it's going to move up or down the engine's torque output. It's going to do it very quickly, as we'll find in the demonstration here in this tutorial. So the mechanical idle control is very simplistic, very effective, but we definitely need to understand the conditions that we have to meet and to program for this to work properly. So first things first, what I would recommend that you do before you turn on your idle ignition control here and do anything with your idle programming virtually, you want to go in when the engine has no feedback through the idle control, specifically for our spark timing control. We can see whatever the ignition angle is showing here, that's going to be coming from our main spark timing table. So if we flip in here, we're commanding approximately 15 degrees. That's what we're receiving essentially at the engine here. If we flip back into idle conditions, we can see again that's represented here. It's approximately 15 degrees. We can see right here the engine speed is showing about 900 RPM, 900,000 RPM. If I want my engine to idle at 950 to 1,000 RPM, I want to move that throttle set screw on a warm engine, so you have to let the engine warm up before we adjust the set screw. On a warm engine, I'm going to want to adjust that set screw so that the idle speed here goes between maybe 1,150 to about 1,250 RPM. What that's going to do. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.